Hello?
Hello. Yeah. Can you hear me?
Hello? Yes,
Okay. Uh, we will continue our discussion of the problems. Noah is also joining, right?
yes, yes,
Oh, okay. So in the last class, we had done, I think, till fourth one. Fifth one onwards, we have to discuss.
yeah,
So question 5 says, find all positive integers n such that 3 power 4 plus 3 power 5 plus 3 power n is a perfect square. Any ideas for this?
Yeah, so I said um, you take out 3 to the power 4 from the entire thing,
Hmm.
and you're left with 3 to the power 4 times 1 plus 3 squared plus 3 cubed plus um, 3 to the power of n minus 4. Then
Hmm.
that equals to 40 plus 3 to the power of n minus 4.
Hmm.
And I said just let 3 to the power of n minus 4 equal 3 to the power of m. So then
Hmm.
And then I said, notice that 3 to the power of 4 is already a square, so you can just ignore that because you want to find where 40 plus 3 to the power of m is a square.
Right.
So I said, you let 40 plus 3 to the power of m equal k squared, or okay, you can say t squared, but that doesn't really matter. Okay, then you get 40 equals to, um, oh, we did not, I let m equal to, uh, you can let m equal to 2t. So we can do
Why?
difference of squares. So you can take it over and do difference of squares. I think,
How are you saying m is equal to 2t? Is it one case or what?
but I'm trying to think now, why did we say, wait,
you,
do
you
you know
know,
why we said,
you know, n is even, and then since m is n minus 4, m will also be even.
Okay, how do you know that n is even?
If you take the numbers in modulo 4, you get that
oh, yeah,
3 to 4 plus 3 to 5 plus 3 to the 6, plus 3 to the 7 is congruent to 0 modulo 4,
The
which means,
addition of all of them.
yeah, it's 0 modulo 4, which means that 3 to the n must either be, if you want it to be a perfect square, it must either be 0 or 1 modulo 4. And 3 to the n, since it's the power of 3, it can either be 1 or 3 modulo 4, which means that 3 to the n must be 1 modulo 4, which occurs when n is even.
Okay. Okay. So basically, you're using the fact that uh, a perfect square can be 0 or 1 modulo 4. So this part has to be 0 or 1 modulo 4. And then
Yeah.
powers of 3, you're taking modulo 4. It will be uh, only 1 modulo 4 is possible, you're saying.
Uh, well, it can be 1 or 3, but since our only option for a square is 0 or 1, then we
Hmm.
can conclude that 3 to the n must be 1 modulo 4, and n must be even.
Okay, so n is even, then n minus 4 or m is also even. And then you will get 3 power m minus k square, or k square minus 3 power m is equal to 40. So then
Yeah.
what? You can call it as 2 times p or something, and you'll get k minus 3 power p, k plus 3 power p.
Yes. And from there, you can just do the cases.
Okay, so 2 into 20 or 4 into 10, or is there any other option?
5.
8 into 5 or 5 into 8.
Yeah.
But we know that k, do we know anything about k? We know that this part, 3 part, do we know the parity of k or something?
K is greater than 6.
That is true. Okay, so uh,
That doesn't
okay,
really help.
how are we eliminating the 8 and 5 case? That's what I'm wondering.
Uh,
Because you can have 5 and 8, right? But
yeah, but
maybe it is too low here. Then p has to be 1 or something, right?
Yes. Well,
If if you
yeah,
use these two, maybe the solution doesn't come. If you add them, you'll get 2k is 13. And if you subtract them, you get 2 into 3 power p is equal to 3, right?
yeah,
So you're getting, this is not possible. This is not possible because
no,
2 is here,
yeah,
right?
yeah,
So you're not getting any solution for 5 into 8, but you might get solutions for these,
mm,
correct?
yes,
So what are your answers coming then?
uh, I think it's
K
6
can
and
be, I
8.
think, 2 or 1
Oh,
yeah,
because
yeah,
2 minus 3 power p and 2 plus 3 power p will be 4 minus 3 power 2p, and
mm,
1 second. No, maybe I'm making a mistake. I think p has to be 2 or 1 because you'll get k minus 9 and k plus 9. So that is k square minus 81 is 40. That fits. You're getting k square is 121, k is 11.
yeah,
And for 1, you get k square minus 9. That also fits because k square minus 9 is 40. So k is 7, right?
yeah,
I'm basically solving it and finding out what is the values of k and p.
yeah,
I'm getting p is 2 and 1, k can be 11 and 7.
yes,
Correct?
yes.
Then your n values are coming as, what are the possible n values? 8 and 6, right?
Mm.
yeah.
Did you get anything like this, 8 or 6 or something?
Oh, yeah. I just forgot to add the 4 at the end, so I had 4 and 2, but it's fine.
Right.
I
So 8
found it.
and 6 are these possibilities, but we have ignored one condition. The one condition that you have not worried about is n minus 4 less than 0. When you took 3
Uh,
power 4 common, you have assumed that n is bigger than 4. So for
Mm.
n less than 4, because you have to only check positive integers, you can directly check for 1, 2, and 3, right?
yeah,
And when you check that, you will realize that 2 is also fitting.
yes,
So
yeah,
you n is equal to 2, if you put, you will get 40 plus 1 by 9 multiplied by 3 power 4. So 81 into 40 plus 81 by 9. So 9. So this is 3249, which is a perfect square, I think.
uh,
Mm.
Because you can take 9 common
Yeah,
here, you'll get 9 into
yeah,
40, 361. This is the
yeah,
perfect square of 3 into 19. 57.
Yeah.
Correct?
Yes.
So basically your final answers will be 2 also and 8 and 6 from the solution that you have done.
Yes.
Okay, sixth one then. Sixth one is find all integers n for which n square plus 2 power n is a perfect square. This question is the question from the final round of Czechoslovakia Olympiad 2022. So such questions are pretty common. So think about it. If you have not tried it, try it now. Or if you have any ideas, tell me.
Aside for this question, um, is
First thing you should notice is if n is equal to 0, you're getting value of 1, which is a perfect square.
Yeah.
yes,
So n is equal to 0 is the solution. Then you should start thinking about, okay, let's think of positives and greater than 0.
Yeah.
Now, here you can divide the problem into two parts. N is even, n is odd. And think of it separately.
Yeah.
So try it for n is even first. If n is equal to 2k, what happens? 2k square plus 2 to the power 2k. So that is becoming 4k square plus, this is like 4 to the power k or something, right?
Yes.
Or you don't need to write it like that. You can just write it as okay, keep it like this. Think of what this implies. 4k squared plus 2 to the power 2k. You guys have not done it yet, right? This question.
I
I
haven't
tried,
solved it,
I
but I
tried
did
it, but
try it.
I think I made a mistake in my work now.
Okay, so try it right now. I don't want to tell you the answer. Just try it for 5 minutes. See if you're able to figure something out. But this is the starting point. N is even, n is odd, and think about it from there. See, this the case where n is even, you're getting this. We can say that 2 power 2k is less than 4k square plus 2 power 2k, right?
Oh
Yeah.
yeah.
And this is what? This is 2 power k whole square. So I'm getting this number as between above this square. And if I can prove that it is below 2k plus 1 square, then it is not possible for it to be a perfect square, right?
Mm.
Yeah.
So let's evaluate this. 2 power 2k plus 1 plus 2 into 2 power k. So that is 2 power k plus 1, right?
Yeah.
So this part, if I can show is bigger than this, then that's it, right?
Yeah.
Yes.
If 2 power k plus 1 is greater than 4k squared, so 2 power k plus 1 plus 1, if it is bigger than 4k square, I think it will be, because you can write it as 2k minus 1 and 2k plus 1. And this is 2 into 2 power k, right?
Yes.
Yeah.
Plus one.
Uh, this is like a quadratic expression here. This side is exponential.
Yeah.
Most likely it will be, this will be bigger. You can possibly prove it by induction. For k is equal to 1, what happens? See, even for k is equal to 1, it is bigger, right?
Yeah. Yeah.
for k is equal to 2 and all, this part will grow much faster than this.
Yeah.
Yes.
1 second. No, right? For
Right.
2, it is not working. Feels like it is not working for 2.
I think 6 and 8 might be the only solution. I mean, oh wait, no.
I mean, we have to just figure out which is bigger. So this thing, four k square has to be compared with this. So okay, what I will do is two into 2 power k plus 1. Is it greater than 4k square? For k is equal to 3, what happens? 2 into 8 plus 17. It is still bigger. And 4 cube. Okay, there is a point after which this will be bigger.
Yeah.
So basically you just have to find that point roughly. If you take
Yeah.
6, what happens? 2 into 2 power 6, so 2 power 7. It is
Um,
128 plus 129 here. And 6 square is 144. Okay, so 7. Now this becomes 2 into 2 power 8 plus 1, 257, right? And
Yeah.
this part is now smaller.
Yes.
So after
yeah.
7, this will be larger than this, right?
Yes.
Yes.
So after 7, there is no doubt that this expression is bigger than this, right?
Yeah.
So,
Yeah.
so therefore now we can say that no solution is possible. No solution where we have a perfect square for k greater than equal to 7, right?
Yeah.
So that means
Yeah.
n should be greater than equal to 14, no solution, right?
Yeah.
Yes.
So the solutions for even numbers can only happen up to 12, right?
Yes.
So for
Yeah.
even numbers, you should have to check 2, 4, 6, 8, 10, and 12, right?
Yeah.
So that is much better than like trying to guess it. Like we use the squeeze inequality and we are able to reduce the whole situation to only a few checks, right?
Yeah.
So for even numbers, I don't only have to check these 6 numbers. It turns out that n is equal to 6 works. It is 36 plus 2 power 6. 2 power 6 is 64. So it becomes 100. So the only
Yeah.
solution for even numbers is n is equal to 6. And 0 was already a solution. Now you have to
Yes.
think of odd numbers. You have n square plus 2 power n. And n can be thought of as 2k plus 1. So this becomes 2k plus 1 whole square plus 2 power 2k plus 1 should be some perfect square. Right?
Yeah.
So we can at least write it as difference of squares if you want. M square minus this square. So m plus 2k plus 1 and m minus 2k minus 1. correct?
Yeah. Okay.
So this is the smaller factor, this is the bigger factor. So we can say that this must be some 2 power A and this must be some 2 power B, right? Where
Yeah.
A is smaller than B, correct?
Yeah. Yes.
Also, notice that both of the factors are having same parity, even or odd. Because you're taking M and adding an odd number or subtracting an odd number from it, right?
Yes.
Yes.
So both will be even or both will be odd, right?
Yes.
Both cannot be odd because then what will happen? It can
Then
never be power of 2, right?
yeah.
Yeah.
So they can't be both odd and odd and give 2 power something, right? So
Mm.
both must be even, no?
Yes.
And if both are even, that means M itself is an odd number, right?
Yeah.
Yes.
Correct?
Yes.
Which makes sense, which was true initially also because we said that N was odd and all, right? Here. Odd plus even is odd only, right?
Yeah.
Okay, so far we have M plus 2k plus 1 is 2 power B and M minus 2k minus 1 is 2 power A. Correct?
Yes.
And
So, and we know that A plus B must be equal to 2k plus 1.
yeah.
So, if we subtract here, we will get twice of 2k plus 1 is equal to 2 power B minus 2 power A, which is basically 2 power A common, 2 power B minus A minus 1 is twice of 2k plus 1. So 2k plus 1 is coming out to be 2 power A minus 1 into 2 power B minus A minus 1, right?
Yeah.
Yeah.
Now notice that this side is odd. So this side also must be somehow odd, right?
Yes.
And this number here is definitely odd. So
Yeah.
is that clear?
Yeah.
So it cannot be that this is even somehow.
Yeah.
So that means automatically the only way to have that is A minus 1 is 0.
Yes.
Yes.
A must be 1 basically, right?
Yeah.
If you put A is
Yeah.
1 in the equations, I think we can figure out B then. So if A is 1, okay, from here we can figure out if A is 1, B is 2k, right? Correct?
Yeah. Yes.
Now from there, what we can say is also in this equation, if I put A is 1 and B is 2k, I'm getting 2k plus 1 is equal to 2 to the power 2k minus 1, right?
Yeah.
So you're getting 2k is equal to 2 to the power 2k minus 1 minus 2. And 2 can get cancelled. And you're getting k is equal to 2 power dividing by 2. So 2 power 2k minus 2 minus 1.
Yes.
Right?
Yeah.
Right. Yeah.
Now, from this equation, we should be able to do something about k. Uh, think about it. K is equal to this. Okay, so
Can you do difference of two squares?
but what squares?
2k minus 1. 2 to the k minus 1 and negative 1.
You can do that, but I doubt it is going to change much. 1 second. Let's think about the situation when k is some big number like 2. If k is 2, is the equality happening? 2 is equal to 2 to the power 2 minus 1. That's not correct, right? K cannot be 2 from here, right?
Yeah.
If k is 3, okay, again, what will happen is this part will grow too fast.
Yeah.
If k is 3, you have 3 here and 2 to the power 6 minus 2 minus 1, right?
Yeah.
Yes.
2 to the power 4 minus 1. It is never going to be equal because this number will grow too fast, right?
Yeah.
For
Yeah.
larger values of k, this left right hand side will be very large. So you can exclude k greater than 2, no solutions, right?
Yes.
We checked at 2, it was not coming, and higher than 2, it also is not coming, right?
Yeah.
Let's check at 1. What happens at 1? 1 is equal to 2 to the power 2 minus 2, 0 minus 1. That also doesn't fit.
Yeah.
So k is 1 is also not working, right?
Mm.
So n cannot be 3, n cannot be any higher odd number, right?
Yeah.
Because 2
Yeah.
onwards anything is not working. So basically n cannot be any odd number. If n
Yeah.
is
Yeah.
equal to 1, we already checked that n is equal to 1 also doesn't work.
Yeah.
And higher odd numbers don't work because this must happen, but this is impossible.
Yeah.
How are we getting it? We got it by finding the values of a and b and then putting it back in this equation. The values of a and b, right?
Mm.
We found the values of a and b by doing x square minus y square formula and then checking, okay, what are the powers that must be multiplied to get to this?
Yes.
Yeah.
So basically for n odd, there are no solutions. And for n even, we already found solutions of 0 and 6.
Yeah.
It is a little detailed, especially the odd number part. The even number part was simple only. But that's what you're expected to do when you're doing a proof. You cannot say just like that, okay, there's no solution. Like there's no, like, you have to show your reasoning. Okay.
Okay.
Question number 7. Find all integers n for which 4n square minus 1 multiplied by n square plus n plus 2019 is a perfect square. This is similar to one problem that we did earlier.
Yeah.
In the beginning, the first or second question that we discussed in this topic, we have to assume that m square, some perfect square, is equal to this thing. You should simplify this a little bit and write it properly. So this will become 4 n power 4 plus 4n cube minus n square minus n plus 2019 is m square, right?
Yeah.
Yeah.
Now, see, this expression is a perfect square, but we also, if you see a similar problem we started off in the beginning, we can also say 4m square is a perfect square, right?
Yes.
Yeah.
So if I multiply this by 4, the reason I'm doing it is I want it to be some square of something, or I want it to be factorized nicely or something. 4 n power 4 is not good, 16 will be better. This is 8076 now, right?
Yeah.
Yeah.
So now, if you think about it, this is 4n square square,
Yes.
then there is uh, I need a plus 1 somehow. I can do a plus 1 square. And this minus 4n square is not good. I can do it as plus 4n square minus 8n square plus 16n cube minus 4n plus 8075.
Yeah.
I'm splitting the 8076 here and I'm writing this and trying to make it perfect square. So this is 2n whole square, this is 1 square, and this is 4n square square. And now you can see how to combine these and get to here. So you'll get it as 2 into 4n square into 1, right? This term.
Yeah.
Yes.
And this term you'll get as plus 2 into 4n square into 2n, right?
Yeah.
Mhm.
And the last time you'll get as minus 2 into 2n into 1. Correct?
Yeah. Yes.
So I'm getting it in the form a square plus b square plus c square minus 2ab minus plus 2bc minus 2ca, right?
Oh, yes.
So this
Yeah.
is becoming 4n square plus 2n minus 1 whole square plus 8075 is equal to 4m square,
Mm,
right?
Yeah.
yes.
Now at this point, it will be useful to know the prime factorization of 8075. You can do it, but I'll just write what it is. 8075 is equal to 5 square times 17 times 19. Okay.
And
So now we can write this as 8075 as the difference of two squares, no?
yeah, you can.
Yes.
And we'll be able to factorize it.
Yeah.
So you can just say that it becomes 2m plus 4n square plus 2n minus 1 multiplied by 2m minus 4n square minus 2n plus 1 is equal to 5 square into 17 into 19. Correct?
Yeah.
Yeah.
Now, this is the larger divisor, this is the smaller divisor. So we have to write this number as a product of two divisors, and you have some choices for the larger divisor, right? Basically, 8075 you can write as a product in many ways, right?
Yeah. Yeah.
So you can say you can do 19 into 5, right? And the remaining stuff in that case would be 5 into 17, right?
Yes.
You can do uh, 1 second. You can do 19 into 17 also if you want. So you'll get 323, I think. And then you will have 25, right?
Yeah.
These are the
Yeah.
possible ways to get the numbers. So these are two ways. Then you can do 425 into 19. Basically, I multiplied all these three.
Mm.
Or you can do 475 and 25 into 19 I will do, right?
Yeah. Yeah.
Into 17, right? And then finally you can do 425 into 5. No, that I've already used. 1, 5, and then 17 and 19. You can do that. 17 into 19 into 1, 5. So basically it is 323 into 5. 1615. And the other
Yes.
factor would be 5. And finally the last one is 8075 into 1.
Yes.
Basically there are these 6 options, right?
Yeah.
So if these 6 options are there, from here, what can we figure out about 4n square plus 2n minus 1? Because it is like 2m plus this expression and 2m minus this expression, right?
Yeah. So you can
Yes.
find. You
So
can
you can
find it.
find that expression by subtracting. So twice
Yeah.
of this expression should be equal to subtracting 95 minus 85, right?
Yeah.
Or
Well,
subtracting this minus this, right?
yeah.
Yes.
Do you understand what I'm saying?
Yes.
Or 406, or this minus this, 475 minus 70, 458. So basically this expression is coming out to be 5 or 149 or 203 or 229, right?
Yeah.
But that expression that I'm talking about is a quadratic in n.
Yeah.
So you can say 4n square plus 2n minus 1 could be any of these values. So what are the values? 5, 149, 203,
200.
229, 805, and 4037. Every
Yes.
time I'm doing subtracting this and dividing by 2.
Yeah.
Basically, I'm trying to find out this one and checking
Yeah.
each combination. And each of these quadratics you can solve to get possible values of n, right?
Yeah.
The solutions will come as only very few solutions will come actually. Uh, find all integers n. You have to find n such that it's an integer. So, right. Just check the quadratics now, it will come. The answer is n is 1. That is one integer. In that case, the perfect square is 45 square.
Yeah.
That is the only answer that comes. Do you understand so far what I have done here?
Yes.
Yeah.
See, there was one question like this in the beginning I had done, first or second question. where you multiply it by something and then try to express the whole product as a perfect square amount. So this is similar to
Yes.
that one. And then we have only 3 questions left, maybe 3 or 4 questions, 8, 9, 10, 11. And those will be the last for this chapter. Then we'll start looking at divisors. We'll do some problems on divisors.
Okay.
So try to do the last few problems here. One more class, basically. We'll finish this and we'll start the discussion of divisors in the next class.
Yeah.
So basically the topics that I want to cover right now are divisors, then number bases, problems on number bases basically, factorials, and then maybe a little bit of a few sessions on tables and games. So combinatorial games type of problems are there. Sometimes number theory is also used. But these are the main topics that I want to do. Each topic we'll be doing like some 10-15 questions, which will help us understand the techniques. Okay.
Yeah.
So right
Alright.
now for our squares and cubes, we have like 3-4 more questions that we need to discuss. So try those out, see how much you can do. And we'll finish that in the next class and try to start the next topic. Okay.
Okay. Okay.
So next class will be like Wednesday or Thursday evening, same time.
Okay.
So you have only few questions, so try them and we'll finish that in the next class. Okay, that's all for now. Let me know if after this what topics you want to do. Like number theory, we have to finish first. After that, what you want to do, think about it, what you need. Find out what you're weak at, those things we'll do.
Alright.
Okay. Okay, that's all for now.
Okay. Thank you.
Mhm.